What I'm going to tell you is this antenna violation and electromigration are related to manufacturing issues. Okay, these are not related to any CTS or routing. Okay, those are different. So that is the physical design flow normally. So that these are the manufacturing defects. Okay, while doing the fabrication and all in the industry, these issues will come up. So we need to predict that in the in while designing our chip only, we need to predict that how much antenna violation should come while doing the fabrication, and how much electromigration should come while doing the fabrication. Like that we are predicting. Okay, so these are PVT or OCV and antenna violation, electromigration, these are all related to manufacturing defects only. Okay, so these you should know, because in the ECO, like that is what, like it is also based on your project. Okay, in some projects PV people will fix these violations, antenna violation and electromigration. Okay, they will take care of these violations. So these will visible in the ECO stages. I mean, after route, we can see how much antenna violation is there in your design, and how much electromigration is there in your design, because we have already designed our chip right up to route. It was completed. So after that, we can see what are the manufacturing defects we can it may come and all. Okay, so in some projects PV people will take care of these issues, but in some projects, that is what, based on your project. Okay, you only need to fix that. Okay, so that's why you guys need to know about this topic. So these are the topics. This may come under your interview questions or not, I don't know. I mean, it depends. Okay, some people will clear this violation and some people don't, but still it will come under our subject only. It's like that. Okay, 50-50 chances. So so that's why I'm bringing these topics also. So if we discuss these topics, that is our theory part will be completed. Okay, so what we are discussing about the antenna violation now. Okay, so what is antenna violation means? So in the fabrication step, so fabrication means like they need to form the layers and all, right? So they are designing the chip actually. So big industries will be there. In India, we don't have any manufacturing unit till now. Okay, in China and Taiwan, only manufacturing units are there. So I think by 2025, they told like in Chennai or something, Intel was started the foundry. It is still in the ongoing process. If it is come, then our VLSI industry will be very good in the India also. Okay, so we don't have any manufacturing unit till now. So we just do the projects here in India. We just do the projects by using the tool and all. We just do the project, but the manufacturing unit means it is. I mean, it costs so many billions of dollars. Okay, uh, to design the layers and all, right? In the SIM cards and all, some gold, copper will be there. So that is the kind of process to design the chips. I mean, like this processors and all it will be. So that is the fabrication process I'm telling. So actual design will be implemented. That is the manufacturing unit. Okay, at that stage, while do in the fabrication steps, so some steps will be there, right? In that stages, these violations may come. Again. Even one minute. Still there's one. Mm. So yeah. So in that stages, these two violations will come. Okay, so that's why after the routing only we can able to see these violations. So there will be one rule. They will follow one rule. Okay, for every violation, there will be some kind of rules will be there. If those are violated, then we can know in our design. So actually, these violations also, we don't know where it will come and all in our design. Suppose your routing is completed. Okay, so you don't know where is your antenna violation is and all, you don't know. Okay, actually I don't know which tool they will use and all. Okay, we just I mean, in two projects I have fixed these violations. Only some full chip people will be there, I told, no. So they just give us the coordinates actually, how they will give, no. So if this is your block, so they will tell like in this area antenna violation is coming, and in this area antenna violation is coming, like that they will give the coordinates actually. In one file they will give the coordinates. So what I'll do, I'll open that file, and right, get selection, and if I give that coordinate, I'll see this location. So if I need to fix, then I will fix this like violation and all. Otherwise it will be like go to PV people. Okay, so these violations are like that. It is like 50-50. In some projects you will be take care of the all these violations, and in some projects PV people will take care of this. Okay, so it's kind of like that. So what I'm going to tell you is this PVT, OCV, antenna, and electromigration. These are not come under any CTS placement or routing. It's not like that. These are all manufacturing related issues. Manufacturing related issues means while chip is fabricating. So OCV and PVT is about like after your chip is fabricating. So it is already your mobile phone is all, it was designed already. So you are operating your mobile phone and all, but how it is behaving, how your mobile phone is behaving when the temperature goes up or when the voltage is goes up. So how it is behaving. So those are all related to that thing. Okay, but this antenna and electromigration is about like while manufacturing, okay, while fabricating the chip. So right, some chemicals will be put to design some layers, some gold, copper, some things and all, platinum, some things and all, it will be poured to form the layers, no. At that stage you may come up with antenna violation and electromigration. Okay, so what is antenna violation means? So every cell, the internal structure will be like this. Every cell will be, internal form will be in the transistor only, right? Usually. So normally normally it will be there. So what is antenna violation means? While plasma etching is one of the step in the fabrication process. Okay. Even I don't know all the steps. So many steps will be there. You can't find it in the nets also. Okay. That will be very secret. Like they won't release how the chip is fabricating. That's why even I don't know. Only for the antenna violation, they told like in the plasma etching stage, the antenna violation will come. That only everybody knows. Okay. So there is one step called plasma etching. Means like etching will happen. So I know like two types of etching will be there. So reminding like some decades ago, they have used it to form some liquid etching. They have done like in the decades ago, but nowadays they are doing gas etching. Some with the gas they are filling the gaps or something. Gas etching is done. So that is what about plasma etching. Okay, etching means some liquid or gas or something will be poured into our layers. Okay, so that is what etching is about. Okay, so while in the plasma etching stage, so there will be a what what to tell, there will be a case that this gate oxide will be damaged. So maybe that gas is not filling that gate area properly or something like that. So that will be the case in the plasma etching stage. So there will be a rule. So if somebody asks what is antenna violation, so this is the formula they will maintain to detect the antenna violation. So this is the rule. Okay, so even that top level people and all, they are telling, right, so here in this area you are having antenna violation and all. How they are calculating? So they are calculating like this. So they are taking this gate area. Okay, this gate area they are taking, and the metal area means the net which is connected to the gate. So this area they are taking. So if these are not met, then you are having antenna violation. Like that, those are predicting the antenna violation. So this is the antenna violation. So definition I'll write. So nothing what I have told, that is the definition. During plasma etching stage, During plasma etching in the fabrication process. Okay, with this tool we can predict the antenna violation. So how we can fix that antenna violation? Suppose if you need to fix that violation, how you can fix? So normally if you see this formula, by this formula wise also we can go. So what is the gate area? Women. Hmm. So we can calculate how much the net length is. Okay, if the net length is very long, as I told you so many times, in the if you come up to the ECO stages, you can every thing, every violation you can fix either by sizing the cell, or you need to see the net how much how much long it is, and you need to break the net. So many violations will be resolved by these two methods only. You don't need to use any clock balancing techniques or placement blockages and all. ಇಲ್ಲ class ಇಲ್ಲ ನಾನು disturbance ಅನ್ಸುತ್ತೆ. ಇಲ್ಲ. Okay, so with these two methods only, so many violations will go away. Okay, so in this antenna violation also, what I'll do first, I'll check the net length. Okay, what is the this net connected to this gate? Okay, so in the tool there will be a one icon will be there. So if you select one cell or something, if you select one cell, suppose if you select one cell and one icon will be there, schematic icon will be there, if you select that, then it will be presented in the gate, I mean like a gates and all, it will come. So normally in the tool, how you will see your cell? So normally like this only you see your cell, right? So normally LVT or HVT, so like that it will be there, one box only will be there. You don't know where the gate, drain, source and all, you don't know, right? So you if you click the schematic option, then this kind of structure will be there. Okay, you can see this kind of structure, like same like this kind of structure you can see, gate, drain, source, how the nets are connected. So like this you can see. Okay, so uh so what I'll see, so the gate, the net which is connected to the gate, no, so that length I will see. So how you can check the net length, no, get attribute, some command will be there, that also I have given already, I think. So with that command you can check the net length, how much the length is there, is it 100 micrometer or 200 micrometer, is like that. So you obviously will know if it is more than 50 micrometer or 60 micrometer, it is long net. Okay, so what you will do, you will break this net here. Means like breaking the net means you are just inserting one buffer in middle of the net. So that is what breaking the net. So net will be break it till here. So you will add one buffer and net will be continued from here. So net is breaking. Okay, so with this also we can meet this rule. I mean we can satisfy this rule. Okay, so your I mean your metal area will be uh, it will be met and your antenna violation will be solved. Otherwise, so one more solution also there. Otherwise what you will do, you will uh, Gina diode, you know, right? Gina diode means reverse biased diode, that you will get inserted in the gate area. So whatever the charge it is coming here, so which is impacting this gate area, whatever the charge it is coming, so etching is happening, no? So suppose gas etching is happening. So if it is spilling more, Okay, at that time we are getting some antenna violation, right? So to reduce this, so like this effect, what it will do, and Gina diode will take that, reverse biased diode it will take, and that purpose is like it will take that charges, and it will the charges will go through the ground. Okay, it won't stay in the gate, and it won't damage the gate oxide. Means how to tell? So this is your gate net. Okay, if etching is happening, so what it is doing, it is breaking this. Okay, otherwise here some holes or something it is happening, some shorts kind of thing it is happening. Okay, I'm just giving the example. Okay, so what we are doing here, we are connecting one reverse bias diode, Zeta diode we need to connect. Okay, so whatever the heavy charge coming from here, it will go to the Gina diode and it will release from here. So it won't damage your gate net. So this is what one of the solution for the antenna violation. So the diodes and all in your design, like there will be one script will be there that it will be given by your lead. Okay, even I forgot that script. So that is one kind of script. It is not like some buffers or cells we can insert. Okay, that will be like depends on your design. What is the diode formation and all? It is different. It is like how it will be. I just so that name will be like diode 2 by 3 2 by 3 TUOP. So like that it will be there, the diode names and all. Okay, this will come under from top level team only. Okay, they will give you the diodes. So you just need to insert this diode over here. Okay, so like this you can solve the antenna violation. So now what you need to understand, no, so everybody, even when I'm not clearing the antenna violation in the first project, in the first two projects, I don't know about antenna violations. Means like theory part only I know. So at that time, I mean like my coaching, like whoever is coaching, I mean giving me the coaching and all, they just told like for the antenna violation, we are just getting, we are inserting the Gina diode. Okay, reverse biased diode, antenna diode also they will call. So what is antenna diode means? That is a reverse biased diode. Okay, that's it. So antenna diode we will insert to clear the antenna violation. That only I know. But when I like saw the real issue, like when I'm fixing the issue, so for every case we don't insert the diode. It is a waste of thing. Okay, if you are inserting or if you are removing from your design, it should be severe case. Okay, I mean like you, if you don't have any remaining things to solve that issue, then only you need to do those things. Why whether either inserting or removing those, that kind of things. Okay, so what I got to know is, so we need to calculate the metal area also. So what is the connected net will be there, that net length also we need to calculate. Okay, we need to include that. Okay, so if it is normal, if it is not having any issue, that net is normal and all, so it is causing no, not I mean it is not causing any delays, the net length is proper and all, then only we will go to the fixing method of antenna diode. Okay, these questions also it will come in the interview. So what I want you to know is, just don't like if you know the antenna violation, what is antenna violation theory and all, it will be okay. But logically there will be some other kind of questions also will be there. That is my point. So if someone is asking the what is antenna violation, what you will tell? So during the plasma etching, so because of that etching, gate oxide will be damaged. So that is the antenna violation. So how we can predict that? There will be a rule. Antenna violation means gate area by metal area. So that we need to maintain. If it is not maintained, then there is an antenna violation in your design. So how you will fix that? Means you can tell like I can apply the antenna diode to the gate. Okay, I can fix like that. Like that you can tell. So still they will ask like, okay, I don't have sufficient diodes available in my design, or I can't like insert the diode over there, there is no space over there, so what you will do? So at that time you need to answer like this. Okay, at that time I will check the metal area also, like which is the net connected to the gate. So that length I will check. If it is very long, then I will break that net. Okay, so if it is not the case, if the net length is normal and all, we must and should insert the diode. Even if there is no space also, we need to create some that space, because this is also most important violation we need to take care. Okay, these can't be ignored. Okay, this can't be ignored. Even like etching is happening, no, like if some one gate is damaged, means like one cell is damaged, means like your whole design will be collapsed. It's like that. Okay, our chips will be like that. Okay, it's not like only one cell got damaged, there won't be nothing effect will be there. It's not like that. Your whole data will be corrupted, and it's like that. Your data won't be proper. That means it is not working, the device is not properly working. Okay, so everything we need to take care. So the every violation, it is important. Okay, so if there is no space, then we need, must and should, we need to create the space. Okay, so like that you need to tell, like that you, how you need to answer. Even for the experienced people also, even for me also, now if they ask some question, first I'll tell, for the antenna violation I have inserted the diode, that's it. Okay, so some people will ask logically, okay, I want another solution also. So what is another solution, like that they will ask. And till now, even I have like 6 years experience too, now also I will answer like same, what I'm telling you, that I'll answer the same in my interview questions also. Okay, yeah, that's it. This is the antenna violation. Okay, anybody have any doubts? So these are all related to, I already told you, don't think like these will be come under routing, because I'm telling after the routing, no, like don't think like this will come under routing, in routing stage or in CTS stage. It's not like that. These are all manufacturing related issues. So after the routing only, you can know, you know about how much antenna violations are there and all. That also you cannot see in your tool. Suppose you have one tool, no, this tool and all. In that tool we can't see, because PD engineers, we don't know how to check this antenna violations and all. These will come from the top level team. Maybe some PV people will do, or some RTL engineers will do. I don't know actually. Some full ship people will calculate this area and all. Okay, but that full ship team people will give us the coordinates. So here in this location you are having antenna violation, like that they will tell. So if you need, if it is your job to fix the antenna violation, you need to take care by this, like this. Okay, either by breaking the net or by inserting the diode. Okay, otherwise it will get transferred to the PV team. So after the routing only you can know about this violation, not before that. Not while you are doing CTS or routing. In your PNR stage you can't know. Okay, so so this is also in the fabrication step only. So what is happening, first I'll write the definition. uh, ఏది 180 ఏది okay, okay. mm, so where are we? Yeah, so electromigration, right? So in the fabrication process, so this is some different kind of thing. Okay, when you high current density passes through a metal interconnect. Through a metal interconnect, the momentum of electrons may get transferred to the metal ions. So the flow of electrons. So this phenomenon is called okay. So what is happening? No. So in the metal layer, so this metal layer will be there. No. So M1, M2, that is what metal layer. Net is different and metal layer is different. Okay. So in this metal layer, what is happening when the high current density is coming? Like when the high current is coming. So current means what? What current means? What is current normally? Are you there? What is current, guys? Electron
Flow,
trans.
yeah, flow of
Yeah,
electron.
yeah, like that we will call it. No. So when the high flow of electrons will, when it is coming through the interconnect means, so through the metal interconnect means this is only in the metal layer. Okay. So in at that time, so when the high force of electrons and the high current is coming, what is happening? So this inside of this electron, so like this suppose, okay, these are ions. No? So these electrons will get transferred to the ions. Ions means like this, it will be there, no? So in the holes or something, they will call ions, electrons in the like B Tech and all we have studied. So it will be transferred to like this because that much of electrons or electron flow is coming. Okay, it will happen like this in the metal layer. Okay, so this metal ions, what this direction will be different, you already know, no? Electrons direction will be different. So at that time we know that like forward bias and reverse bias, at that time electron flow will be like this and electron flow will be like this and all. So what is happening? The metal ions may get follow in the direction of electrons. So metal ions also, this will get transferred in the electron direction. Okay. I mean, like this, it will happen. Even I don't know. I mean, we don't check like how the electrons are forming and all. We can't check in the tool. Okay. This is the theory concept. Okay. Like this, it may happen in the fabrication stage. Okay. When the high current is coming, when the high current density is coming, like like this process and all, it may happen in the metal layer. So this effect we are calling it as electromigration. This is what the definition. So in the definition, what you need to tell, in the fabrication process, when a high current density comes through a metal interconnect, the momentum of electronics may get transferred to the metal ions. Okay, the metal ions may get follow in the direction of electrons. So this phenomenon is called electromigration. Nothing is happening. So some heavy flow of electrons are coming. So that directions are under switching actually. Electrons are converted, may get transferred to the ions, and ions direction also it will come under the electrons. Okay, the direction also changing. That is only happening. So this phenomenon we are calling it as electromigration. Okay, so how we can fix this electromigration? So there will be two ways actually. So either you need to increase the width of this metal layer. Okay. So if you increase this width of the metal layer, then there will be sufficient area to get the it will withstand that, it will bear that high current density if you increase the width of the metal. Okay, it will bear that high current density. So suppose in this fit it is not bearing. Okay, that's why this phenomenon is happening. So if it can bear, then it will be proper, right? Normally only it is doing it is doing that work. So this is one of the way. Either you need to increase the width of that metal layer, or the same thing we need to follow. We need to like check the what is the length of that metal layer. Okay, what is the length of that metal layer? If it is more, then again we need to break that metal layer by using buffer and all. So like that also the problem will be solved. Okay, so maybe this metal interconnect, what it is, maybe it is very long. Okay, maybe it is not able to withstand that high current density. So what I'll do, I'll break this, and for this high current density is happening, and for the like this, how I mean high current density is happening, so it will be normal. So these are the two ways to fix the electromigration also. One thing just remember, okay, so in the PNR, whatever you are doing, like placement blockages or path grouping or bounds you are applying, keyboard margins you are applying, those and all that you can do in the PNR stage, because in the PNR stage we can't change an at least. Okay, that breaking the net or you are sizing the cell to LVT HVT you can't do. Okay, because the net by the net list wise we need to like maintain our design, like we need to fix our design. That is what we are trying in the PNR. By these commands wise and all, we are just telling the tool to fix this violation. Okay, bounds you are applying, so that means you are telling the tool to create some bound over there and keep the cells over there. Maybe because of that your violations are reducing. Okay, even path grouping also same. You are telling the tool to fix your timing violation. Apart from that manual thing you are not doing. Correct. Even for the magnetic placement also, even for the clock balancing also, because in the PNR we don't have any authority to change the net list. Okay, suppose with those methods maybe you're having some 1,000 picoseconds of violation. Suppose if you have applied some path grouping over there and your timing came to 300 picoseconds of violation. Okay, so 700 picoseconds of violation got reduced, right, without changing any net list. Maybe if you size it to some LVT or HVT, maybe your time will come to zero. But still, without changing that netlist and all, you have met like 700 picoseconds of violation, right? So that is what the thinking is about for everybody thinking. So in the PNR, actually for simple blocks and all will be there. No, so for those blocks and all with those commands only, your timing will get fixed actually. So that is what the thing is. So for the only like complex blocks and all, it may not get fixed. Okay, so that's why what we are doing, so after the routing is completed we will go to the ECO stage. We in the every netlist we don't go to the ECO stages, remember that. Okay, for every project there will be netlist will be releases. It depends on your project. In the Qualcomm we are having only 3 netlist releases are there. After the 3 netlist, that's it, your project is closed. You need to do ECO and you need to submit your design, that's it. But in the AMD 7 netlist releases. Okay, after the 7 netlist only you need to, I mean like ECO stage will be there. ECO phase means your chip is taping out. It is already went to fabrication stage. It is already went to China or Taiwan. All project went to already there. Okay, So it's like that. So in the ECO only, you already know about the spare cell functionality and all, no? So with that spare cells only, we are able to change the size of the cell, like LVT to HVT or HVT to LVT, or breaking the nets and all. So many violations will be resolved by these two methods only. Whatever the violation will come, even I'm telling you in the ECO, we need to fix the DRVs, set up violations, hold violations, long nets, and antenna violations, electromigration violations. For all the things, same methods only I have applied actually. Even for the antenna diode also, I haven't inserted. By breaking the net only, my antenna violation got resolved actually. Okay, so like that it will happen. So breaking the net, if you decrease the net delay, cell delay, that is enough in your design. The ultimate point, at last, what it is, no, you just need to decrease the delay, whatever it is, whether it is net or whether it is cell. Okay, so that is the point. So in every, like for every problem, I'm telling that 2 to 3 ways are there. Even for the antenna violation, what is the 2 ways? One is we are adding the antenna diode, so that is a special case for the antenna violation, suppose. So another case, how to resolve the antenna violation means, that is same, again we are breaking the net. So that is what the solutions are for everything. Okay, even for the setup violations, or even for the DRVs, everything we are doing what we are doing. So that is what you were analyzed, like when you went to some project, you are freshers, no? So when you went to some project, what you need to observe, no? So you need to observe the cell delays and net delays morely. Your concentration will be on those. Okay, not on the commands and all. Like, I'm not telling commands means, at the end of the stage, those will be your those are only causing the delays, those are only spoiling your chip. So your concentration will be how to reduce that, either net delay or cell delay. In PNR stage, you are applying some commands to the tool, that's it. But after the PNR stage also, you need to reduce the net delay and cell delay, whatever the method you can use. But that is the most ultimate thing. Okay, so here in the electromigration also, what I am doing, so maybe this is a special case for the electromigration, increasing the width of the metal. So in another case also, we will do the increase the width of the metal layer. In which case, crosstalk also, crosstalk violation also, we will do the same, no? For the clock nets, we are applying India rules, right? Double width, double spacing, triple width, triple spacing. Because this metal layer, suppose if there is a thin metal layer, then it can't withstand the clock switching activity. That's why we need to increase the metal width. Okay, suppose if it is 1 micrometer, suppose one width is there, so it is not withstanding the clock switching activity. That's why we are width we have increased by 3. Then it is withstanding the clock switching activity, then everything is fine. So in the electromigration also, same is happening. So it is not able to withstand the high current density. Okay, so what I'm doing, simply I'm just increasing the width of the metal layer. So means like I'm modifying that to, I'm changing that capability. Okay, so your capability is not like this, your capability will be like this, you can withstand this high current density. That is what I'm telling that to metal layer. Okay, that's what I'm doing, I'm just increasing that width. So so that is what, so this case you won't apply blindly. So if there is an antenna violation in your design, don't go and apply antenna diode over there blindly, you can't do that. Okay, first you need to know, do the simplest things. Okay, these are the, adding the antenna diode, or this changing the, increasing the width of the metal layer. These will be secondary cases. Maybe for you, these are the main fixing methodologies for the antenna or electromigration, but normally in reality these will be the secondary cases. First, what you need to know, for anything you need to check the net length, how much your net is causing the delay. That is what you need to check. Okay, if that is fixable, suppose you have already break the net, but still if it is not fixing, then you will go to this method. Obviously, I mean 100% accurate, this method will be fixable. I mean this method will fixes your problem, whether it is electromigration or I mean antenna. If you insert antenna diode, obviously that surely in 100% it will fix your problem. But it's not like we need to do it first. You guys are getting my point. For anything, my thing I am going to tell you is, for anything, for every problem, first you need to do the simplest solution. Okay, if it is not working, then only you go to the biggest one. Okay, this is not working, so what I can do? So like that. Okay, even for the crosstalk we have discussed about the shielding and all, like shielding one layer and all we need to provide to fix the crosstalk. Okay, normally if some I mean any people like freshers or experienced people, how you will fix a crosstalk means shielding I will apply, like that only they will tell. But in the reality, that is theory. Okay, for every case there will be one kind of solution will be there, that is that kind of solution. But in the reality it's not like that. Even for the crosstalk also we will check the net length, how much the net is causing the delay, how much the cell is causing delay. If you make that cell to causing the delay very less, no, then it won't affected by the crosstalk. That's it, simple. Finish, your crosstalk is fixed. If it is not fixing, even if you break the net, or if you already some HVT cell is there, suppose if you change it to LVT cell, what it will do, it will cause very less delay. So your crosstalk will be less. Okay, still if it is not fixable, no, then that time you will provide the shielding. Okay, at starting you can't blindly provide the shielding, because shielding means one layer you are creating. No, that will cause so many. It will cost so much, and also area also you're occupying, right? Area also you're occupying some. Okay, so like that you need to think. So what is your job? What is physical design engineer job? No, you need to decrease the area and decrease the delay. I mean, like decrease the delay means improving the timing, okay, and improving your block performance. That is what your job. So in any way, like for every problem, you need to think like that only. Okay, so that is what my point. So theory classes are completed. Actually, okay, without wasting time, we'll just go to the tool. I want to show you guys one thing. Mm, cannot. Anybody know the password? Dollar PD? Okay. Okay. What I need to give, like institution. Okay. You don't have congestion in your thing, no? My congestion is not coming. Yeah. Actually, you don't have much congestion in your design, okay? Why it is not? So no, you know, right? These are your macro pins. Okay, these are the pins, and these are the tracks. How? So somebody like if you are experienced and know, they will ask these kind of questions also. What is your row length? So how you can calculate the scale? Can use the scale and you can measure this distance. Okay, it is 1.672. Okay, like that you can calculate. Why? But in your design, I think there is no congestion in your design. I think I told you, no, like this map will be there. So this is how the map will look like. Okay, I think you don't have any congestion in your design. So normally red color and see this is kind magenta and yellow, green, light green, green. So only one net is there, but that is also not we are not able to see. I don't know. Maybe we need to actually with the global route congestion only we can able to see. Okay, current design. Okay, here I think it is giving the numbers. You don't have any congestion, guys, in your design. So in the global route congestion only, see hard level I kept. Okay, I just give the reload. Okay, so here the numbers are showing. No, so you don't have any congestion in your design. Here it will present. I already explained in. Huh? Here. Okay. So where we have discussed about the place. Yeah. Here we have discussed about the congestion, no? Like these colors will be there and see here numbers will be presented like that. So same like that it will be there, but you have zero congestion in your design. But still you can try with the placement blockages and all, okay? Though no need to like you can try. So what you can do, no? Like here you can select the placement blockage and zoom it. Suppose if you want to apply the 1 minute. Suppose suppose here you need to I will disable the pins. ఏం కాదులే మావే. Okay. Just I'm pressing Z, okay? I'm pressing Z, I'm zooming this area. Okay. So I told no, like while you are doing the macro placement itself, you can create the placement blockages and all. So here you can create. Okay. So like this. Okay. So like this you can create. So if you do that, so CAD selection, see how it is coming PB underscore 0. So how you will apply, I have given the command. So just try that, okay? If you have any doubts, you can ask me. So, so here I have given how to apply the keyboard margins, bounds, everything I have given. Just execute this command. So what I have done, so I have done in the GUI area. Here create option. So here in the create option, I have just clicked the placement blockage. That's it. So in the GUI option also you can create. So what I have created, so here you can change your what type of blockage you are creating. No, so hard, soft, partial only if you want to create, or allow buffer only also it will come under soft only. So like that. Suppose if you want to create partial, okay. So like that. So in the partial means you need to give the percentage also, right? Partial means what, like you need to block some area and you need to allow some area. So you can like anything you can keep here. Okay, and you need to create it like this. That's it. This is your partial blockade. Like this only we will also do. Okay. So if you do the CPV1 is coming. So mm, okay, B box means a hyphen B box I have given. So B box means it will give you the coordinate. Okay, so this is what the coordinate which you have applied. Okay, so why I'm telling you how to check this coordinate, no? So if you want to execute that by command, so there will be command also, right? Create placement blockage. So you need to keep somewhere. Suppose if you want to keep this recipe in some file, so like this you need to do, right? So hyphen type hard or soft, like this you will give. Okay, or partial. Okay, hyphen b box, hyphen boundary, and this boundary you can give. If you give like this, same like that it will apply. Okay, so if you want some area, suppose if you want to keep in which locations we will, so how we will do the port placement and all, no? So like this we will apply the port placement also actually. So here in this area, so here in this area some 4 ports are there, right? What I'll do, I'll just take this partial placement blockage and I will apply to this area. I mean, I don't apply. First, I'll do like this, and I will just do the coordinate like B box. I'll do. So I will have some value, right? I will have the coordinate, right? So according to that, in that coordinate, I'll just do these ports. Okay. So in this location, these 4 ports will be there. So how I can delete again? You can easily delete this also after you, if you get the B box and all, after you get the coordinate and all. If you just do the delete option, it is not fine. So here also it is giving the B box actually. Blocked percentage 15 I gave. So this properties and all how you can do. So you can click any, suppose if you want to macro properties or anything, just give the right click and go to the properties. Okay. So here it will give all the, what is the name, what is the class placement blockage, what is the type partial, what is the blocked percentage 15, what is the B box. B box means boundary. Okay. That coordinate. Okay. So like that it will do. Actually, in my delete option is not coming. How we can delete D? D I have pressed. Okay, so I will create again. See this name, it is coming PB2. Any name you can change. Okay, PB. I will keep Rajita. Okay, so here I have applied the soft. Okay, so if you want the B box, so what I'll do, it is already selected. That's why it is highlighted. No, so what I'll do here, get attribute. Get attribute, get selection. You already know, right? When you are highlighting something and you want that in the like command prompt, you need to do the get selection. After that, you, if you have already know the name, then you need to do the chain selection. Okay, and I'm giving the B box. So this is the B box I'm getting. Otherwise, in the GUI also you can see. So this I was highlighted, and I'm just going to the properties. See here, PB Rajita. This name is PB Rajita, and placement blockage, and blockage type is soft. And what is the V box? What is the boundary? Here it is coming. Okay. So how you? So you already know the boundary and all. So you will. I mean, you need to keep this recipe in somewhere, right? In some file, you need to keep. So when you're applying any blockage or something, what you need to do? You need to keep that in some file. Then only it will apply to the next stage, right? So if you're not keeping that file, it won't apply. So if you have already applied, so what you will do, if you want to delete it, so just press D. This will be deleted. Okay. So like that. So I have given some commands just to see how these commands are working. Okay. If you don't know, just I gave if your interview purpose also it will be useful for that. Like I have gave for the I mean like power placement also. But just to see here it is showing like the direction of VSS and VDD, how to create the VDD and VSS also I have given. Okay, power plan, and where I have given mm, initialized floor plan. Okay. Okay, okay, actually I gave commands also. Here I think it is not coming. Okay, I'll give you I have already the commands also, okay. I will paste that in the group. How to create bound, how to create keyboard